and welcome everyone to the section of video in which I am discussing about the tryptophan operon, and in this particular video I will be discussing about the attenuation process of tryptophan operon. There is two mechanisms by which the tryptophan operon works. First is by the regulation and second is by attenuation. And in the process of regulation, what happens is all these structural gene, they will form mRNA, and this mRNA will code for an enzyme. This enzyme will again synthesize tryptophan. This gene will code enzyme will synthesize tryptophan. This tryptophan will go and bind to the upper pressure. The upper pressure will be activated, and that activated pressure will go and bind to the operator, and thus RNA pole will fall off from the promoter, and hence this process will stop. Alright, that is the first mechanism. Now talking about the second mechanism, and the video for the first mechanism has been uploaded by me before this one. You can have a watch on that and can come for this. Now coming to the regulation by attenuation. Alright, now coming to the attenuation process of tryptophan operon. Now what is there is in between the structural gene and the promoter and operator, there is a leader sequence. Alright, these are structural gene, they are working with a different mechanism, and this particular section of gene, it is working with a different mechanism, and this is known as leader gene. TRPL you can write here, and then it codes for leader mRNA, and these leader mRNA, they have a 4 sequence, that is sequence 1, 2, 3 and 4. Alright, now sequence 1 and 2 has ability to pair with one another and form a hairpin kind of structure. Likewise, sequence 2 and 3 also have an ability to pair with one another and form a hairpin structure, and again sequence 3 and 4 also has an ability to pair with one another and form a hairpin structure. Now why are sequence 1 and 2 hairpin, 2 and 3 hairpin, and 3 and 4 hairpin different from one another is because, in what sense are they different from one another is because this is 1 and 2. Alright, because if 1 and 2 hairpin will be formed, the process will be paused, and if 2 and 3 will form, it is anti-termination hairpin, in which the process of the formation of polypeptide chain will continue, and the last one is termination. In this, the process will be halt. Now the first thing which is very important to know before understanding the mechanism of the hairpin is, in this very process we are not talking about the transcription level, but we are talking in the translational level. Alright, here in the first case we were talking about the transcription level, because in first case we will concern about the RNA polymerase to sit in the promoter and then make mRNA. If the RNA polymerase do not sit, means our process will stop. If the RNA polymerase will sit, means our process will be on. But in this case we are not talking about the transcriptional level, that is not talking about the formation of mRNA, but we are talking in the case of translational level. Alright, our mRNA has already been made. The work of RNA polymerase has already been completed here. Alright, we are not talking about transcriptional level, but we are talking for the synthesis of the polyformation of the polypeptide chain. In the process of formation of polypeptide chain, what is the mechanism going on, and how will the process continue and how will the process stop, that is we are talking about in the process of attenuation. So what happens is, we know that in case of bacteria, the process of transcription and translation, they go hand in hand, because intron, alright, because these bacteria, they do not have a non-coding sequence or intron, they have only exons. So what happens is, our RNA, this is my, for example, this is this sequence is this, our leader sequence is been forming, RNA polymerase is forming a leader sequence, alright, it is somewhere here. At the same period of time, the ribosome will come and sit, and they will start synthesizing polypeptide, alright, the process, and that is why we can say that the process of translation and transcription is going or is happening at the same period of time. Our RNA polymerase is, my RNA polymerase is somewhere here, it has synthesized the mRNA, and it is somewhere here. At the same period of time, ribosome is sitting, and now it will also continue to make, it will go and go, it will also go and go, right? This is the scenario. Now what happens is, if, alright, now coming to the cases, if there is less concentration of tryptophan, less concentration, TRP is less, what happens when the tryptophan is less? Ribosome will come and sit in the first sequence, alright. RNA polymerase has made the sequence, for example, it is somewhere here now, okay, transcription has been done, now it is for the translation. And one more thing to tell is, this particular sequence is, it code for a short stretch of polypeptide chain, that is 14, it contains the 14 amino acid polypeptide chain. This sequence codes for a polypeptide chain with a 14 amino acid, and within that 14 amino acid there is continuous tryptophan 2 times at the start point of the sequence, alright. Now one more time I am saying, this sequence will code for 14 amino acid, polypeptide of 14 amino acid, and within that 14 amino acid tryptophan, there are 2 alternate tryptophan, one by one, continuous 2 tryptophan are there at somewhere start of the sequence, alright. Now for example, it is synthesizing 1 tryptophan, 2, and then another, and likewise it will synthesize 14, alright. Now we know that the condition is, there is less tryptophan. There is less tryptophan in the cell. When there is less tryptophan in the cell, ribosome require 2 tRNA coded with tryptophan one by one, because these sequence code for 14 amino acid which has 2 tryptophan one by one at the start point, right? So it needs 2 tryptophan coded tRNA. If it does not get that 2 tryptophan coded tRNA, then it will wait. It will wait for a while till that tryptophan coded tRNA will come and sit here, right? It is the process, right? So it will wait for a while. Now this process in which the ribosome wait for a while in the sequence 1 is known as stalling. Alright, means our ribosome will stall at sequence 1 if there is less concentration of tryptophan, because it requires tryptophan to make polypeptide chain. Now, and during this process what happens is 2 and 3 can pair with one another, forming this hairpin known as anti-termination hairpin. If they will form anti-termination hairpin, means if 2 and 3 is pairing, right, means now 3 and 4 cannot pair, isn't it? When 2 and 3 is pairing, 3 and 4 cannot pair. So termination hairpin will not be formed. This means the process will continue because the synthesis is not much now. The cell has not overcome the extent of synthesis, means cell still require this polypeptide chain to be made in a numerous fold. So after it will get the tryptophan, now the process will continue and it will go on. This ribosome will go on and it will pass. For example, now it will get tryptophan, the process will go on and ribosome will sit over here and it will again synthesize 3, and then again it will sit here, it will again synthesize more and it will go. Alright. Now the means if there is less tryptophan, the ribosome will start at sequence 1, means 2 and 3 can form a hairpin loop, and so anti-termination, since the anti-termination hair loop is formed, the process will continue because there is no chance of formation of termination hair loop as the 3 and 4, as 3 is not vacant, 3 is already pairing with 4. Alright. Now when the level of tryptophan is high in the cell, if the level of tryptophan in the cell is high, then what happens? This ribosome will not start in the sequence 1. Ribosome did not start in the sequence 1 because there is excess of tryptophan in the cells. So it will come one by one in a very speedy way, and this will pass. And ribosome will synthesize the polypeptide chain in the very numerous fold, and when there is excess of synthesis, now what happens? Cell do not need excess of anything, right? Excess of synthesis of this very polypeptide it is not required by the cell. So what it does, it wants the process to be halted because excess of energy is getting wasted. I don't need this much of thing, so let's halt the process. So what it does is, now what happens during the process of making a polypeptide, what happens? These ribosome will stop a while, for a while here, somewhere here, half of 1 and 2. It will capture both 1 and 2. It will stop for a while in between 1 and 2. Alright, at the end of sequence 1 and at the starting of sequence 2. Okay, when there is excess of tryptophan in the cell, then what happens? After making a numerous fold of polypeptide, at some point when there is much more polypeptide, then the ribosome will sit in the middle somewhere covering half portion of 1 and half portion of 2 sequence. Since the sequence 2 is now half consumed by ribosome, it will not be able to pair with 3. Means the sequence 3 is not vacant now. When the sequence 3 is not vacant, sequence 2 is not vacant, now sequence 3 has every possibility to pair with 4. Since sequence 2 is not free, sequence 3 can now bind with sequence 4. Right? When sequence 3 and sequence 4 they form a hair loop, then what happens? They form a termination hair loop. If the termination hair loop is formed, ribosome will not be able to pass this hair loop. Ribosome will easily pass the anti-termination hair loop, but ribosome will not be able to pass the termination hair loop. So now what happens? These 3 and 4 will pair. This is the scenario. Now ribosome is continuing the synthesis of polypeptide, and it waited here for few seconds, for microseconds, and in this process what happens? They made a hairpin. So now this ribosome will not be able to pass from the termination hairpin loop, so it will stop here and the process will halt. Alright. So, and in this way there is the regulation of the operon, there is the attenuation process in the tryptophan operon. Now what happens? Let us recap it one more time. Leader sequence, it codes for the another mRNA, and this mRNA has sequence 1, 2, 3 and 4. Alright, and the sequence 1 has ability to pair with 2, 2 has ability to pair with 3, and 3 has ability to pair with 4. When 2 and 1, when 1 and 2 will pair, they will pause, and the possibility of pairing of 1 and 2 is very few, very less, because ribosomes, it always start the synthesis from 1 and 2, right? So ribosome is always covering the 1, so the pairing of 1 and 2 is very much less probability. Now when 2 and 3 will pair with one another, they will form anti-termination hair loop, means ribosome will pass from them, and thus 3 and 4 hair loop will not be formed, and hence the process will continue. Right? Like, the meaning of formation of anti-termination is only that the termination hair loop cannot form now, the process will be continuing. Right? So when the tryptophan concentration is low, then the anti-termination hair loop will form, because ribosome will stall in the sequence 1 and wait for the tryptophan to come, because these segments code for the 14 amino acid in which the tryptophan, there is 2 tryptophan required at the starting of the amino acid, polypeptide chain. Now when the anti-termination hair loop is formed, the process will continue, right? Because the polypeptide has not been synthesized much, because there was less concentration of tryptophan, so the cell want the process to be continued, so the anti-termination hair loop is there. When the now another condition, when the tryptophan concentration in the cell is more, then what happens? Cell do not want excess of this polypeptide, and so what happens is it will wait in between 1 and 2 for a while, so that 3 and 4 they form a hair loop, and when 3 and 4 form a hair loop, they form a termination hair loop, and then from which the ribosome will not be able to pass. If ribosome will not pass from the termination hair loop, then the process of translation will stop, and hence the synthesis of tryptophan, or the synthesis of polypeptide will also stop, right? Now, okay, now telling the differences between the two type of regulation is that in the first type of regulation, the transcription, the process is halted in the initial level of transcription, because if the repressor will bind to the operator, the RNA polymerase will not be able to bind to the operator, right? So the transcription will be halted before the start point. All right, means initiation will not start. But in case of the process of attenuation, the initiation of transcription has already been started. Ribosome, our RNA polymerase is somewhere here. Means the process will be halted in between the process of transcription. After initiation of transcription, we can say. Means in first case, the process will be halted before the initiation of transcription. In second case, the process will be halted after the initiation of transcription. And in first case, the process will depend on, the regulation process depend on the concentration of tryptophan inside the cell. But in second case, the attenuation process depends on the concentration of tryptophan loaded tRNA, right? It depends on the concentration of tryptophan loaded tRNA. And in this process, what we learn is the transcription and translation, they go hand on hand. This is the perfect example which shows that in case of bacteria, the transcription and translation, they occur simultaneously, right? And this is the much fine level of regulating the expression of the gene, right, as compared to the first mechanism. And this was only for today. Thank you.